This video will be discussing some of the best practices and procedures to ensure you acquire the best NMR titration data possible for analysis in Titan. This will be a short video where you can find more information will be discussed at the end of the video. Field strength can be used when acquiring data. Using an NMR spectrometer equipped with cryogenic probes will also provide greater experimental sensitivity and allow titration to be completed rapidly. 5mm tubes are most convenient for carrying out NMR titrations, requiring a sample volume of 550 microliters. What's most important is that the sample volume is accurately controlled, so we do not recommend the use of Shigemi tubes as they would likely cause sample loss. Prepare protein with uniform 15N labeling according to standard expression protocols. Protein samples should be prepared in a buffer with a strong buffering capacity to avoid pH changes during addition of ligand. Since instead of chemical shift values, only chemical shift changes are required for the analysis titration data, we recommend that the reference DSS is not used during titration experiments, as it may interact with the protein, potentially introducing systematic errors into the results. A high concentration ligand stock should be prepared in an identical buffer to the protein to avoid changes to the solution conditions. If for solubility reasons the ligand is dissolved in DMSO, D6-DMSO is preferred to avoid strong background signals from the solvent, and a control experiment should be performed to verify that DMSO at the maximum concentration used during the titration does not perturb the spectrum of the protein being observed. The protein concentration shouldn't be more than an order of magnitude higher than the KD value. Optimal results are obtained when the protein concentration is similar to that of the KD. A ligand stock should be prepared with a concentration 5 to 20 that of the final desired concentration to minimize dilution of the sample. The final ligand concentration should fully saturate the binding, the greater of at least 3 times the KD or 2 equivalents relative to the protein concentration. The majority of the ligand concentration should be in the range of 0 to 1.5 equivalents of the protein, unless the protein concentration is much less than the KD, in which case sufficiently high ligand concentration should be used in order to fully saturate the binding. We recommend acquiring 8 to 12 titration points. Centrifuge protein stocks at 16,000 rpm for 30 minutes to remove precipitate or aggregates prior to the measurement of concentration. Low protein concentrations may require acquisition times of several hours for each spectrum. Higher concentrations, around 50 to 100 micromolar, will obtain significantly high signal-to-noise ratio in less than an hour. Optimize the sample temperature prior to titration, as the temperature affects the quality of NMR spectra. Make sure to acquire data with a pulse sequence that is implemented within Titan, which are HSQC and HMQC experiments. As a result of more complex spin dynamics involved in the magnetization transfer step, Choudhury sensitivity enhanced HSQC and in-phase HSQC experiments are not compatible. 1H 15N correlation experiments, SOFAST HMQC and HSQC are preferred. The SOFAST HMQC has great sensitivity with short acquisition times and good resolution. However, transverse relaxation and chemical exchange broadening are generally more severe in the indirect dimension of HMQC experiments compared to the HSQC, and therefore in some cases the HSQC may provide more useful information. Avoid short relaxation delays in SOFAST HMQC experiments used for 2D line shape analysis to ensure that the resonance intensities are not strongly weighted by longitudinal relaxation, which may vary between free and bound states. The suggested acquisition times are 100 milliseconds for direct dimension and 30 to 50 milliseconds for indirect dimension. Record a 1D hydrogen spectrum of the unbound protein sample as reference. Make sure to select an appropriate 2D experiment. Remove the sample from the spectrometer and add the required amount of ligand stock solution to the sample. Careful to not lose material due to adhesion to glass pipettes. It is not recommended that you remove the sample from the NMR tube, but instead add the appropriate volume of liquid stock to the tube. A hand centrifuge can be used to return the sample to the bottom of the tube, careful to avoid bubbles which could interfere with acquiring accurate data. Make sure to allow time for the temperature to re-equilibrate upon reinserting the sample into the spectrometer. Lock shim and recalibrate the 1H 90 pulse length. Record a new pair of 1D and 2D spectra, and repeat from the second step until the titration is complete. Know that for analysis in Titan, it is essential that acquisition parameters such as the spectrum widths and offsets are not changed between experiments. The number of scans and receiver gain may however be varied between points as required to obtain high-quality spectra. For more information, refer to the article NMR line chip analysis of intrinsically disordered protein interactions, from which the information for this video was obtained.